Hello everybody, my name is Kristina Halma. I work with Farming Smarter as a research assistant, and I'm going to give you updates on the two projects that I've been the most involved with in the just about 2 years that I've been working with Farming Smarter. The first one is on-farm Fusarium head blight management in irrigated wheat, known to us simply as the Fusarium project. So this project has run for 3 years. We're just kind of in the process of wrapping it up now. Funded by the Pest Management Centre of Agriculture and Agri-Food Canada. And this project is looking at the use of fungicides, irrigation scheduling, and cropping system for managing Fusarium head blight on the farm. And there's kind of two components to this project. There's a field trial, so field scale research this is, with 9 different producer cooperators, as well as a 25 field survey kind of looking at cropping practices that are influencing the development of FHB in fields across southern Alberta. Here's a little map that just shows kind of the general areas where our cooperators are. So they're scattered throughout 4 different counties, municipalities. Somehow we managed to miss Tabor. I don't know how that happened, but lots close around the border there. So just a little bit of background on Fusarium head blight, if anybody isn't aware of the disease or not very familiar with it. It is a disease that can overwinter here, but it also can blow in from long distances, the spores of the disease, or from a neighbor's field. And it's characterized by bleached spikelets that turn color a lot earlier than the rest of the head, so it really sticks out just before the heads start turning. And then there's also kind of a pinkish orange, almost salmon colored spores that show up on the infected spikelets. And oftentimes it does only affect 1, 2, 3 spikelets on the head, not necessarily the whole head. And the kernels that are affected by this disease are kind of chalky and shriveled in appearance. And the big thing with this disease is not only the loss in yield caused by these unhealthy kernels, but also DON, it's called. It's a mycotoxin, and that's the main one that accumulates when this disease does infect the grain, and that makes the grain unfit for human or animal consumption, even at relatively low levels. The best management practices we are looking at, fungicide application, as well as irrigation management. So by irrigation management, I mean eliminating irrigation during the flowering period, which is the prime infection period for this disease, and kind of tailoring your water application around that. Both reduce the visual ratings of Fusarium head blight, the Fusarium damaged kernels, which is the main measure of this disease in harvested grain, as well as the DON levels. So we saw the worst Fusarium head blight in 2010, the first year of this project. So the biggest reductions were seen at that year. 2.4% FDK, which is huge, was caused by avoiding irrigation during flowering, and 5.5% reduction in Fusarium damaged kernels due to fungicide treatment, also in 2010. And then we had one field where we were able to actually combine these practices, and it showed that using both practices together actually did produce better results than either one by itself. Overall yield was slightly improved by fungicide use in the majority of fields, and avoiding irrigation during flowering kept yield at about the same, or sometimes there was a slight drop up to a maximum of 5%. But when your quality is improved, that's something that many farmers are willing to look at. And another big point was that the improvements seen by using one of these two best management practices were greater in wheat classes and varieties that were more susceptible, which makes sense, right? So we had the most dramatic results in durum, because that is the most susceptible class overall of all the wheat classes to Fusarium head blight. So we recommend that if you're growing a susceptible class, you try to find a variety that has a fair or good FHB resistance rating, because that will reduce your chances of getting the disease even before you're looking at fungicide application or changing around your irrigation scheduling. So Dale Khalil from Alberta Agriculture was able to do an economic analysis for us on the results from 2010 and 2011. We haven't got the 2012 stuff together yet. But we see here this is change in net benefit and percent Fusarium damaged kernels in amber durum. And so you see that for two of the points there was a great improvement in Fusarium damaged kernels due to putting this irrigation management in place, but no net benefit. So that means that the grade did not change. But the third one, you see there was only a very small improvement in percent Fusarium damaged kernels, and yet there was a net benefit somewhere around $1.75 a bushel. And in one of the next slides, I'll explain why we did it in dollars per bushel as opposed to dollars per acre. So you see that's a really, really huge benefit just with irrigation management. Now this is the same, it's for durum, but this is looking at the fungicide application. And you see that there were some pretty big, on the more towards the right-hand side of the chart, there were some pretty big improvements in percent Fusarium damaged kernels. It was down a lot as opposed to the areas that weren't treated with the fungicide. And the net benefit there ranged from about $1.50 to $2 a bushel. Now you might wonder what that point is doing way over off to the left. That one, we got caught, frost. 2010. It was a late crop, and there was a lot of frost damage. So that's why there was not a net benefit, because it was downgraded due to the frost. Now this one is in hard red spring, and this is also with a fungicide application. And you see that there's kind of 4 points over there in the top right. Those are all positive. That means that a net benefit in dollars per bushel ranging from about 33 cents to $1. And then the other ones, and those ones, again, we got caught by frost. That was 2010, late year. Everybody knows how 2010 went. So you got to be careful looking at fungicide applications if there's some sort of other factor that might not get you an optimum crop in the end. If you think you're going to be caught by frost, if you think you're going to be low yielding for whatever reason, you might want to look twice at that fungicide application, because yes, you want to protect your crop as much as possible, but as always there's a trade-off, and you do have to look at your bottom line. So why did we measure this in cost for return per unit of output as opposed to acre? It's because when you look forward, you need to budget per acre, but when you look back, it's important to consider output, because it takes into account varying yield and your price. Something which, if you do it per acre, that doesn't capture that kind of influence. And then you can make better informed decisions based on that, rather than just on a per acre basis. Just thought I'd throw in a picture there. That one's a pretty good one, kind of shows the two things we were looking at, spraying and irrigation. And then the other part of this project was the survey. So we did 25 fields per year for 3 years, did visual ratings, and then took samples and got them tested for Fusarium damaged kernels and the mycotoxin DON. And a few things jumped out at us when we were looking at that. Irrigated fields in general had higher levels of infection than dry land. But that, excuse me, that we kind of expected it because it was more concentrated, we know from the provincial surveys, in the irrigated areas. And also, the biggest factor seemed to be whether the disease was in the area or not necessarily that the cropping practices had as much to do with it as we were expecting. Also, whether or not it was irrigated during flowering played a smaller role than we expected. Now we also have to take the weather into consideration in that case. There was a lot of moisture in 2010, 2011. So probably most of those fields got rain showers, even though the irrigation was kept off during that time. Differences in variety susceptibility played a smaller role. Again, that's likely because of the frequent showers that we got in those couple years. That increased the ability of the disease to get into that crop. So it's important to know your fields and the ones around you, and to know if you have that risk, if you are in a risky area, and then take a look at your cultivar susceptibility. So in conclusion, both of these best management practices did work to reduce disease levels, but they do work best in combination. However, if you're only able to do one, it's still certainly a lot better than nothing. It's very important to consider whether the disease is in your area, so get your grain tested and see if it is a concern in your area or not, and then decide which measures you want to take to manage it. Consider how susceptible your class and variety of wheat is, and consider changing that if you are in a risky area. And also look at your anticipated return on investment before you alter your variety, your fungicide regime, or your irrigation scheduling. And then very quick, I'm going to go through another project we have, the Contans and Serenade project. These are 2 biofungicides, also by the Pest Management Center of AAFC. It was to demonstrate how these 2 biofungicides controlled Sclerotinia diseases in canola and dry beans. So in dry beans, it's called white mold. We also had 9 field scale trials in 9 different fields, and a small plot demo. Again, scattered throughout southern Alberta. The disease, probably most everybody knows about Sclerotinia and white mold, but just quickly, it overwinters in the soil, and it germinates in the spring, and the spores infect a wide variety of broadleaf crops. The main ones in southern Alberta that are of concern are canola, dry beans, and I believe sunflowers as well, though this project didn't look at that. And it infects the stems, leaves, and or pods, and causes them to die prematurely and rot. Contans is a biological product. It's basically a fungus that attacks the Sclerotinia fungus in the soil. And it's wholesaled by UAP in Canada, produced by a German company, Profita. It beats Sclerotinia to the punch. It gets rid of it before it has a chance to germinate and infect the crop. So instead of having to try and get it on the crop, it gets it before it even has a chance. Serenade is a foliar fungicide, a biological one, also distributed by UAP. It suppresses numerous fungal diseases, including Sclerotinia diseases, in a variety of crops. So for this project, we had a few different treatments. It was kind of complicated. Each farmer could kind of do a few different things. So it was interesting to try and analyze the results. We did have a couple untreated checks, but for the most part, Lance was kind of our baseline in the dry bean crops, which was the majority of the fields. Here's one of the most positive results we saw for Serenade. In a lot of cases, it was actually fairly similar to Lance in terms of yield, but in this one, it definitely did out-yield the Lance by about 200 pounds per acre in dry beans. This is the most positive one we saw, and kind of the most, what we expected in terms of Contans results. A real stair-step effect there. You see on the left, that is just Lance. Then Contans at a lower rate is the second bar there. Contans at a higher rate is the third bar, and both of those had Lance foliar applications as well. And then the furthest one there on the right was only Contans applied for 1 year, because Contans is a multi-year product. So you're wanting to apply, if you have a heavy level of infestation, you're wanting to apply that 2 or 3 years in a row to really get that population down in the soil. There's the stair-step effect. So Dale Khalil again did an analysis for us on this. This is yield change versus untreated check. And you see everything obviously yielded better than the untreated check, but really our baseline was Lance. So that's on the next slide. And you see here the orange arrows are Contans just by itself, no foliar application, and this is in dry beans. Purple is Contans plus a Lance foliar application, and green is Serenade. So you see we had not many positive results in 2010 because that was the first year for the Contans to work, but the second and third years we definitely had a more positive response. And here's the net benefit, so taking into account yield and bean prices and all that. So again, orange is Contans, purple is Contans and Lance, and green is Serenade. So you see we definitely had some good positive results there in the second and third year, and we're keeping on monitoring these fields for this past year and this coming year. This past year we didn't have we unfortunately didn't get the results we were hoping for. The one bean field we had was hailed on twice, and the canola field we had was quite late, so we didn't get disease infestation because of those. So Contans isn't likely to replace other fungicides, but it might be a really good idea to consider it in conjunction with other ones. Maybe if you can reduce one fungicide application, that would be really great because it's applied at a different time than a lot of other products, so it might fit better into your schedule. And also, if Contans really works from year to year, it might allow a more intensive rotation of susceptible crops like canola and dry beans. And that's the end.